This is a worked solution to AQA Physics P1 June 2014 higher tier paper question 8. Question 8 is about efficiency. In the table it compares three different light bulbs and gives us their efficiencies and asks us to calculate the useful power output. It also gives us the input power. So the equation from the datasheet that links these two things is efficiency is equal to useful output power divided by the total input power. So substituting our numbers in, for the CFL bulb, our efficiency is 0.42, and that's equal to the useful output power, which we don't know, I'll call that P, divided by the total input power, which is 14. So rearranging, multiplying each side by 14, P is equal to 0.42 times 14, and that is 5.88 watts. In part 2, it asks us to calculate the waste energy produced each second. Well, for this you need to recognise that power is energy produced per second, or energy converted per second. So what this is really asking us is what the waste power is. If we know the input power is 14 and 5.88 watts are converted usefully every second, then that input of 14 minus the useful must be what's wasted. And so that 14 minus 5.88 is 8.12. And that's 8.12 watts, which means joules per second, which is what the question is asking for. Question 8 part B asks us to think about that information in the efficiency table in a little bit more detail. So it's saying currently it's lit by halogen bulbs, and if you change to use LED bulbs it will reduce the cost of running the cabinet. So first of all, because LED bulbs are more efficient, the input power would be less. So that's the first point to make. Also, it would produce less waste energy. Which for a light bulb is heat. Now, if less heat is produced, it would mean that the cabinet is cooler, and that would also mean that the cooler unit would not need to be used so much, which would also reduce the amount of power used. So if we say the cabinet would be cooler, so the cooler unit would be on for less time. In B part 2, it wants us to recognise that the rate of growth of a plant, i.e. the length of a plant, is a continuous value, and the intensity of light is also a continuous value. So the type of graph you would draw for that is a line graph, because both variables are continuous. In 8c, it wants us to compare the efficiencies of the two types of bulbs and compare the cost of buying and using halogen bulbs rather than one LED bulb. And we have to do some calculations for this. So first of all, we should see that a halogen bulb's lifespan is 2,000 hours and an LED bulb is 48,000 hours. And so for one LED bulb you would need 24 halogen bulbs. So that means the cost of halogen is 24 times £1.50 plus the operating cost, which is 24 times £16. Now that comes out as a total of £420. The same calculations for LEDs is, well, we only need to buy one LED, which is £30, plus the operating cost of the LED, which is £67.20, means a total cost of £97.20 for running the LED bulb. And so the statement that the LED overall cost is cheaper, and including those calculations and the actual costs, would get all the marks for that question.